Okay, so cooling is actually we are withdrawing a heat from energy. In the same way, we can look at from this opposite side as well. If we just give heat or heat here or heat over here. So how can we define latent heat? Is actually the change in phase without change in temperature. It's actually a change in phase without change in temperature. First it was vapor, which is steam is vapor phase. There are three phases: solid, liquid and gas, right? Solid, liquid and gas. So if we're changing the phases without changing in temperature, first it was vapor, which was is 100 degrees Celsius, but if we just cool down, it becomes steam, which is at 100 degrees Celsius. Again, if we again cool down, it becomes water at 0 degrees Celsius. Again cool water, it is 100 degrees. So there are some changes in some stuffs where the temperature doesn't change, but actually the phase is changing. If we just look at, you might understand this more clearly through graph. Okay, so if I just plot a graph, let's say this is a graph, this is 100 degree, this one also it's 100 degree, 50 degree, 0 degree, then minus 20, 30 degree. So this is temperature. If I heat an object, so the let's say some object is at minus 20 degrees Celsius. If I heat the object, okay, so if I heat the object, if I supply heat to the object, then what will becomes, its temperature increases to 0 degrees Celsius. Not object, let's say water is we are taken water as an object. Okay, so the water is at 20 degrees Celsius firstly, and if we increase the if we heat the water is minus degrees Celsius, exists as vapor phase, right? So it is at vapor phase. Sorry, what the fuck I'm saying. Okay, so water is 20 degrees Celsius, exists as ice, right? So if we just heat this ice, then its temperature slowly increases. Its temperature slowly increases and reaches to 0. Again if we supply heat, then its temperature, the ice becomes water, so here is becomes water. And again if we heat, then its again temperature rises and gets to, we supply continuous heat at 100 degrees Celsius. What happens, this water is at 100 degrees Celsius convert into vapor with the application of some heat, which means its temperature is not going to change. Again if we heat the object, then its temperature remains constant, and then again it becomes heat, it changes to vapor. So here are two things, see here. So this is what is latent heat. Remember, the temperature are not changing. See, at 0 degree temperature are not changing, but we are supplying heat such that ice is becoming water, right? Also here we are supplying heat such that water is again becoming vapor. So there are two steps over here. So it is first where the ice is converted into water, we call it latent heat of fusion. Latent heat of fusion. What is latent heat of fusion? It is the conversion of ice into water without change in temperature. Neither temperature do not change. So temperature do not change. It has got fixed value. Okay, it has got fixed value. And what is it? It is 50. It's 50. 58. 540. Sorry. 80. 80 calorie. Okay. So what is latent heat of fusion of ice? It is actually a heat to change the phase without changing temperature. Hope this has you understood. And at this point, so what is this? At this point, this is latent heat of vaporization. Latent heat of vaporization. What is this? It is just simply when we convert water into vapor, which is it. This is also 100 degrees Celsius. This is also 100 degrees Celsius, but we supply some heat. Same here, temperature do not change. See, temperature is not changing, but we are supplying heat over here. So this is what is latent heat of vaporization and latent temperature. So we also discussed latent heat is done, right? So we have done latent heat, and this is where our topic ends. Hope you understand. Now let's discuss some questions about it. Okay, so we'll be discussing some things. So now let's come back to this question: can we change the temperature of an object without the heating? What do you think? The answer is yes, right? We can do this. Yes, a big yes. A big yes. But how? This is homework. This is homework, okay? If we already discovered that heat and temperature are two different things, then definitely we can change the temperature by heating an object. And you know, I would like to ask another question at this point. Is can we boil water at 50 degrees Celsius? This is your homework. Just think about it, do it. It's a very intuitive question. You get to learn more things. It's also homework. Okay, can we boil water at 50 degrees Celsius? Now we are done with this lecture. Now let's move on to do some questions. I'll do some questions. How about okay, I bring some questions related to heat. We'll be only doing some questions which are important or which are discussed. We'll be not doing questions which are not important at all. We're not doing those questions. First question. What does it say? The value of the value of minus 30 degree Fahrenheit scale. Same question, see? This is just a conversion factor. We already discussed over here. Same, we should apply this formula and we'll do. See, for question from this table. So, what is the... You pause the video, try, okay? You first pause the video, try to answer it. And then if you done, then only play it, okay? Otherwise, try to do it first and just somehow, try to do it. Okay, so hope you have tried it. Now, a very simple question. Just apply the formula C minus 0 upon orange. Which color should I pick? Green. Okay, so let's just pick color. Let's pick this color. So it's simple. C minus 0 upon 100 minus 0 upper fixed point minus lower point fixed point. Fahrenheit scale minus lower fixed point upon upper fixed point minus lower fixed point. And just we can put it the value of Fahrenheit. Sorry, Celsius always given and we can find F. But we have also discovered another formula, and that says C equals to 5 by 9 F minus 32. And what is C given here? Is given minus 30 equals to 5 by 9. F is to be found and 32. Solving this 5 9 6 are 30 6 9 are 54 equals to F minus 32. So solving we get F equals to 51 minus 22. So minus 22. What is it? Is minus 22. So this is what is this? I don't know, but this is the answer. Let's get to another question. Consider the following statement: Fahrenheit is the smallest unit. Question. This is a very easy question. This is homework. Okay, I'm just writing homework. What is this? What about this? Fahrenheit was the first temperature scale which was measured. What is this? This is also your homework. Okay, just try to Google it. This is a factual question. Factual question. Factual question. The temperature for which an object. This is a very important question. Important. The temperature for which the reading on Celsius and Fahrenheit scales are identical. Means at what temperature? Okay. So what temperature both the Celsius scale and Fahrenheit scales coincide. Okay. So this answer is minus 40 degree because I know I have already by-heard it. You should also by-heard it. From now point, you should know at 40, at minus 40, the Celsius scale and Fahrenheit scale are identical. Let me prove it. Let me prove it. If you don't believe me, I'll just prove it. Say. So we know Celsius scale equals to 5 by 9 F minus 32. So question is asking at the point that scale are identical. So let's just say C as X. Let's say identical at X number, and 5 by 9 is also X minus 32. If we solve it, we'll get 9X equals to 5X minus 16, 160. So 4X equals minus 160, which gets 440 minus 40. See, at minus 40, the Celsius and Fahrenheit scales are identical. So this is very important, okay? Temperature of the measurement depends, hardness is the degree of hardness, we already discussed it. The highest instrument is a pyrometer. And let me talk about this one. So pyrometer, what is pyrometer? Is actually used to measure the temperature of sun. It is used to measure the temperature of hot objects, okay? So the question is says highest fixed point. Since pyrometer is used to measure the temperature of hot objects like suns, definitely they should have highest fixed point. So we don't know what spirometer is and what hygrometer is, but we know calorimeter is used to measure heat. So this is point. P and Q are two objects. The temperature of P is greater than that of Q. This means that temperature of P is greater than that of Q, which means what is temperature? Temperature is actually hotness or coldness. So kinetic energy, we already discussed kinetic energy directly equals to temperature. Means if there is more kinetic energy, there is more temperature, which gives more, so yeah, which gives more temperature. What is kinetic energy? Kinetic energy is a total energy. Kinetic energy is not average energy, right? Kinetic energy is the total energy. If P temperature is greater than Q, then it must have the P's total energy must be greater than total energy of molecules of Q. As we know, kinetic energy is equal to temperature. Simple. This is your homework, okay? You just very easy. Its answer should be. Let me just solve it. Temperatures differing 50 degree on Fahrenheit scale must be different. Let's check it. Let's check this is correct or not. If we just put 45 on the scale, differ by 45 on the Celsius, on Fahrenheit. So let's just put 45 on the Celsius scale, and then let's see the Fahrenheit scale comes 45 or not. Okay, so 45 equals 5 by 9 F minus 32. So 5 9 is 49, 9 9 is 81 equals F minus 32. So F becomes temperature differing 25 on the Fahrenheit scale. No, this is not how we do it. It's a blunder. This is a differing, this is change is given. So we actually use this formula. Change wala formula. Let me show you here. Which formula we are using? We are using this formula. So using this formula we get what we get is 45 to 5 by 9. So 5 minus 5. Change becomes 981. So this is wrong, right? So you just again you do this and again do this and again do this and check it which comes and then just check it. This is wrong, okay? So mercury thermometer is in clinical thermometer. Absolutely true. This is true. Mercury shines. Does Mercury say no, right? Mercury never shines. So what is there? So which of the correct? Only one is correct, right? Specific heat of a substance depend on. Specific it already discussed. It neither depend upon heat nor it depend upon any other things. It just depends upon nature of substance, which we called material. We already did that. It's already done. Paper pressure, no, don't do this. Two bodies A and B are of same mass and same amount of heat is given to both of them if the temperature A decreases more than if the temperature of A decreases more than that of B because of heat addition, then we don't have to discover here. No. Thermal conductivity doesn't come into role in this question. So just think logically. It's a very logical question. We already know S equals to Q upon M upon dt is the amount of heat required to raise the temperature 1 kg mass by 1 degree Celsius. Since the temperature A decreases more than that of B. Okay. What the fuck is this? So if the temperature of A decreases more than that of B, which means if the temperature of A decreases more than that of B because of heat addition, this simply means the specific heat capacity of A is less than that of B. Since the specific heat capacity of A is less than that of B, it simply says the A decreases more than that of B. Okay, so just think logically. I'm not explaining it because I'm tired of speaking. It's like how many hours I'm talking. You just do your work. Okay, especially with the amount of heat correct. The specific capacity, it is almost correct. This is wrong. Gases also have a specific capacity. Gases also have a specific capacity, but it is gases. Gases pressure and volume changes. So we measure a specific capacity constant pressure or constant volume. So it 1 and 2. Cooking utensils have low specific angles. Yes, obviously. You know why? Because high conductivity means we have to make food in, if the material have good conductivity, then our heat can be easily transferred and the cooking would be easy. And low specific means the more amount of heat is transferred in less heat more temperature is rising or more heat is given in less temperature without rising this material temperature. Specifically the amount of heat required to raise the temperature of a unit mass, this is also correct. Both 1 and 2 are correct. We don't need to do expansion. So match the following. What is it? So bimetal is thermal solution, steam engine is energy conversion equals radiation forms. We can do it easily. Okay, so what is D3 one option? Just think it's not a big deal. If you only know one, then answer will come. Okay, I mean steam engine is just energy conversion is steamed into that, and electric fuse is just melting. When the electric fuse is melting, the electricity rising is very important. So this is a factual point. I have already written the temperature scales in my videos. You can, if you have watched the video, then you can do it. But I guess the answer is coming. Freezing point of ice is everybody knows B1, and B1 is in one option. See, we don't even need to remember. So latent heat of fusion of any body. I already discussed this. So what is always same. Fusion of any body. Latent heat is also same because what is the latent heat of fusion of ice? What is that? It was 80. I already discussed. It was KT, which is fixed. No matter it's a fixed, so every body has its own latent heat of fusion or latent of vaporization. Water is used in hot water bottles in preference to other liquids. It's omok. You do omok. So this is no need to do. There's no need to do. We don't need to do evaporation. Water is covered by evaporate. No need to do. Heat energy of an object is total energy of the molecules of the object, right? A glowing electric bulb becomes hot after filament. This is a good one, but I'm not discussing in this video. I will be discussing about conduction, radiation and convection in another video, another topic. Okay, so diesel engine, no need to do diesel engine. If there were no atmosphere, the average temperature of the surface of the earth would be. This is a good question. Let me explain this one with red pen. If there was no atmosphere, there is sun, let's say this is sun and this is earth. So this atmosphere layer, this layer of atmosphere. atmosphere. Okay, so what is actually is when the sun rays, the radiations coming from sun rays, when it strike into the earth's surface, and it can't escape, you know, due to the thin very thick atmosphere. So the gases are trapped here, sorry, radiation are trapped here. No, so the radiations are trapped here due to this atmospheric layer, which increases the what earth temperature. This is what we exactly call, you know, global warming. This is what is exactly is global warming. So the earth temperature is increasing due to the trapped radiations coming from the earth due to the atmosphere. Okay, so question says, if we just remove this atmosphere layer, if we just remove this atmosphere layer, what will happen? If we just remove this atmosphere layer, the earth come and the you know radiation can easily escape, which means there is no trapping of gas. Since there is no trapping of gas, there is no global warming. Since there is no global warming, there is no rise in temperature, so it has to be lower. Transfer of heat rays from sun to moon, how radiation works. This is topic from this thing, you know, from this thing. We'll be discussing in later videos. Material is for, I already described this. Look at here. Here it is already given. If you want to know in details, you can just. This is homework now. 164. 2 is all that, you know, statement questions. Look at here, all the statement questions. Yeah, this is homework. Okay, from there to 164 to 171 is homework. Your homework. The blackboard is black because it, I mean, what is color? Color is actually when the light reflects things. That's what color. Black is actually when the body observes everything. There's no, you know, black hole. Light even can't express. So we can't see it because light can't even reflect from here. So it observes everything. So it just does not reflect any color. Since it does not reflect any color, observe everything, the blackboard seems black. Well, there's no need to do. I know the answer, but just consider this. No need to do, but this is, if you want to remember, just remember the temperature of stars can be determined by wind's displacement. You need to do this. This is an interesting question. You just have to write that. You know, when let me just give you the concept. When there is, let's say this is a room and there is a refrigerator and there is a handle. You just open this refrigerator. You know, the air inside, air present in the room gets into the refrigerator. When this air gets into the refrigerator, this room will become more warm because the air is getting into the refrigerator. Means what is happening? More, you know, the air is becoming more warm, so it will just heat the room. This is a very much, you know, famous question. It's a famous question, so you just can by heard it, you know. So you don't need to you just find refrigerator, heat the room. So that's it. The gas used in refrigerator is no need to do this refrigerator. So this is a homework. You have to do this previous year questions. Do this. This is also your homework. Screenshot, okay? Homework. Now this is done, okay? Heat topic is done. And hope you just pause the video and do every questions. And if you're just stuck in some questions or you don't know the concept, you can use Google or you can ask me